What's going on, guys? Let's try this problem right here. Here we have a vector function and the question is asking to find the limit of this, right? Now let's see how we can find it. To find the limit, what we are going to do is we are going to take limit t approaches infinity, and the first function is sine square t over t square in the I direction, right? And the second one is cos square t over t square in the j direction, and the third one we have e power minus t in the k direction, right? Now what we are going to do is we are going to take the limit of each of them and see what we get. That's going to be the final answer. Now let's go ahead and write this one differently, like limit t approaches infinity sine square t over t square in the I direction plus limit t approaches infinity cos square t over t square in the j direction, and the last one is going to be limit t approaches infinity e power minus t in the k direction. Now let's see how we can solve this one. And here if you see sine square infinity, so here we have this one does not exist, right? Sine infinity does not exist, and t square, so this is some undefined variables. So here what we have to do is we have to use the squeeze theorem. So when we have cosine, we can use cosine, we can use squeeze theorem. Now let's go ahead and use the squeeze theorem for this one. And we know that sine value, whatever the sine value, it must be between -1 and +1, right? Sine t is going to be between -1 and +1, but the sine square t cannot be negative, so it must be between 0 and 1, right? Therefore sine square over t, sine square t over t square must be 0 over t square, that's going to be 0, and 1 over t square. Now we have to take the limit of each of, like, therefore the limit of this one is going to be between limit of these two. So limit of t approaches infinity 0, that's going to be 0 anyway because we don't have any t, and the next one limit t approaches infinity sine square t over t square, and limit of 1 over t square, right? T approaches infinity, and this is 0, and this one is what we are trying to find. T approaches infinity sine square t over t square, and if you substitute infinity for this t, that's going to make this one 1 over infinity. That's going to be definitely 0. So if this is between 0, this must be also 0. That's what squeeze theorem says, right? So therefore we know that this is going to be 0. The first limit is going to be 0. Again, the second limit, same approach. When we have cos, again we can use the squeeze theorem. We know that cos must be between -1 and 1, therefore cos square t should be between 0 and 1, right? Therefore cos square t over t must be this t square, right? T square must be between 0 over t square, that's going to be 0, and 1 over t square. And again, if you take the limit, this is going to be 0, and limit t approaches infinity, this is what we are trying to find, cos square t over t square, and this is also, if you take the limit t approaches infinity or 1 over t square, again this is going to be 0. So 0, and this is going to be remained here, and this is also 0. Since this is between 0, this also must be 0, right? And let's try the third one. Third one we should have written like this. Instead of e power minus t, we could have written 1 over e power t. Same thing, right? E power minus t is same as 1 over e power t. And if you substitute infinity, we are going to have 1 over infinity. So this is also going to be 0. So we can write our final answer as 0 I direction plus 0 k direction, j direction plus 0 z, k direction, right? 0 k direction, k direction. So also you can express this one as 0 comma 0 comma 0, right? So this is going to be our final answer. So the limit of this vector function is going to be 0 0 0, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.